we can really introduce the promoters, the species. Okay. So we start from here, carrier material. Carrier 在一起 ，carrier material 在一起 ，carrier。Okay, so in most industrial reactions, number of reactor molecules converted to the products in a given time is directly related to the number of what? Number of catalytic sites, right? 跟这个催化的位置的大小有关。Okay, is directly related to the number of sites. Okay, 好，那个公式的都是可以上台大生物技术系来的。那我这个系不能不正常，我也不太知道，我才疏学习不太知道。如果有一些化工材料这些，当然会有情况，不是很有。生物的话，研究单位。Okay. The number of sites available to the reactor. Okay. So active site, the number of active sites is very important. Okay. So it is necessary to maximize the number of active sites by what? By dispersing the catalytic component. Dispersing. By dispersing. Okay. So as you know, the number of active sites is very important. The higher the active site, the higher you may get the higher ratio rate. Right? So it is necessary to maximize the number of active sites by dispersing the catalytic components onto a porous material. You have to have a porous material. 多孔的才能够更高的表面积嘛，你分散比较好，对不对？你把1克的重力分散在表面积20，跟分散在表面2000，分散是很差，对不对 ？OK。So why you need porous material? Because you need to have a high surface area. Okay. So you have to maximize the surface area of the catalytic components such as platinum, iron, rhodium, platinum, copper oxide, radium oxide, copper, and so forth. So forth increases the number of sites. Okay. 是这么多啦，再去的 so forth increase the number of sites， 增加位置的数目。Upon which， 在上面干嘛呢 ？Upon which chemical and catalytic reaction can occur. Chemical 是什么？化学系统。And catalytic reaction can occur. 催化反应可以存在。Okay. So carrier is like a support. Like a support. For example, like carbon, like aluminum oxide. Aluminum oxide. And this is carrier or carbon. CO2. Okay. This is a carrier. Okay. So catalytic components are introduced into the carrier by intervention from aqueous solution. 含剂就是有过滤到这个含有这个金属的溶液里面的 intervention。Okay. So you have platinum ion, you dissolve into a water, aqueous solution, water. Okay, when you put the carrier and carbon, you mix it together. And that process is called impregnation. Okay, but that process you can take a catalyst called. Okay. So maximizing dispersion of catalytic component require what? Require the area with high surface area. Okay, as high as possible, right? So people use a zeolite, please, zeolite, or micro force material, or not meso force, meso force material. Okay, so you want to maximize the dispersion of the catalyst. Okay, you need to have area with high surface area, such as aluminum oxide, silicon oxide, titanium oxide, carbon, silicon oxide, and oxide, hydrogen base. Okay, zeolite base. Zeolite base. Okay, zeolite. And CO2, zero oxide. Okay, so in most cases, common sense in most cases, carriers themselves are not catalytic active or specific. In most cases, 但有些会有但是 in most cases， 大部分的 carrier 没有活性But even though they don't have catalytic, we have catalytic active. Okay, and they can make an important role in promoting what? In promoting the activity. 都会帮助活性activity, and also selectivity. 它也会帮助选择性selectivity. Okay, they can improve activity and selectivity and maintaining the overall stability. Stability. And durability. They can maintain the overall stability and durability. Durability. Of the finished catalyst. OK， 这两个都是稳定性，这两个差在这个 stability 就是说你放在那边它都没有反应的条件下面，树苗会坏掉。OK， 就你放着它没有反应树苗会坏掉，叫 stability。durability 有点像耐用度，耐用度就是说你在把它升到高温是500度 C 的，它可以很稳定的反应几个小时。这个是在反应条件下面，这个有个耐用度。stability 有点像是化学稳定性，它那边它多久不会坏掉。Okay, so the stability is more like a chemical stability. You put the chemical there and you stay. You leave it there for like 1 month, 1 year. So how is the structure and property change? But durability is much like you in the saturation conditions. So how durable your catalyst can behave? You can it's durable. You can have like 10 hours waiting at a very high temperature. in chemical and petroleum application, many different catalytic structures can be used. Right? They are like cylindrical, like a pellet. Right? There are different forms and different structure can be used. Okay, so the structures depend on what? Depend on the number of factors such as the volume of product. So how much volume of the product will how much okay, or the addition of the store of heat, or thermodynamic equilibrium, or need for bigger regeneration cycle, right? OK， 就是你选用哪一种触媒结构，跟你要产量多少，这反应都是跟你说加热或者是打热有关联。这些触媒的结构会跟它产生热、先热的对流会排放不一样，对力学平衡有关，跟你需要再生。Okay. So the catalyst structure used these factors. Okay. So the catalyst is presented in a shaped particulate. Okay. Shaped particulate. Shaped particulate 就是把它压成锭嘛，就是这个锭里面呢。里面有很多触媒跟载体 ，OK， reshape particle, this is reshape particle, right? So inside you contain the catalytic component and disperse on the carrier. So here's a little tiny catalyst powders you pack together to become a reshape particulate. Okay. So here's a cylindrical shape, a hollow cylindrical shape. Okay, the column, the rock shape, chloride. This is a pellet type. So the size of shape of the catalyst you use. You want to use this one. Depend on what? Depend on the nature of flow or permitted pressure drop and requirement for the heat management. Whether it is exothermic, or endothermic theory, and the mechanical strength, 机械强度等等啊。Okay. So there are many factors influence how you select the shape particulate. Okay, you choose this one, or this one depends on some factors like the flow rate, right? You have pressure drop, right? 还有公司所交付对，如果你的颗粒越小，会有很大的压降，对，颗粒很大的时候，你的压降就很低，那就会跟反应一样。上过我那个法医工程，按压力一下，有压降的一个抗力来，你在选的触面大小。压降，这跟触媒大小有关，那你有一个 ，OK， right, the permitted pressure drop is very important. Okay, requirement of heat management is 这跟你的热水heat transfer related to heat transfer. Okay, you have unit operation, like the unit operation class 2, unit operation 2. Okay, thermal transfer, heat transfer. The first one is unit operation 1 is momentum transfer, 2 heat transfer, 3 mass transfer. Okay, so you design a reactor, you have to consider a mass transfer and also a heat transfer, exothermic and endothermic, and then 10 millimeters, how many uses? Okay. So the desired ratio case feature goes through the bed of making cannot go. 这个叫做填充槽。The bed of taking cannot 是我们反应工程学到的填充槽。This is a taking bed. Take it back. Okay, we have taken this in chemical engineering. Take it back. Okay, so the gas mixture through take it back. And reaction partners. The effluent gas effluent gas 反正是好分不清 effluent gas outlet gas. Okay. Effluent gas is often monitored with some type of analytic devices, such as GC. Okay, GC 是去分析反应场 GC to monitor conversion, right? Monitor conversion, GC 记下记忆啊 ，GC。Okay, so how about temperature? The temperature inside the bed is often measured at several points to monitor the reaction using using thermocouple 热电，用热电 thermocouple。Okay, because here we have to make very low, like 10 meter low, so you have to monitor several points, monitor temperature at several points. Okay. Monitor the reaction. We're using thermocouple. You might see this thermocouple in the furnace. Since the furnace, you open the furnace. You see there's a nickel wire. Okay, that is thermocouple. Okay, measure the temperature. So this is how it looks like. Particular catalyst for fixed spec reactor 就是固定床反应器。那好，叫 fixed spec reactor， 我们有流动床，对不对？有两种，你知道吗？流动床那种有点像，没有那种大热洞，有上面有风吹，然后上面有球那种，那个就流动床反应器。好 ，this is fixed spec. Fixed spec is catalyst fixed at a certain position. Okay, for the catalytic reactor, in general, we have two kind of reactor. One is fixed bed reactor. Okay, the catalytic fixed somewhere, and second one is fluid dice. Fluid dice that reactor. Okay, the reactor will be online. Then you have a catalyst. You have a catalyst. If you have a suspend and rapidly flow in this area, so that the reacting gas through this flow catalyst and react with the reactants, and you have a product from here. Okay, this is flow dice bank. Okay, this bank is reactors not going to fix somewhere. So, for example, like here, you have the feed here, right? Then you have the source of heat. You have the heat like 500 degrees Celsius. You have some hole spring. Fix the catalyst here. In order to prevent the catalyst flow through here. Okay, so as you can see, a very kind of catalyst structure. The roll line and spherical and different shape of catalyst. Depends on many factors. Flow rate, pressure, temperature, okay. 选的跟很多种原因来选的，所以它需要有反应工程的一个设计的概念，来都知道跟它选大还是小颗的，跟你的产物啊、流域什么都可以出，现在都用电脑的，现在用电脑算，像我们同学在做那个还有时候讨论，大家做那个就是那种像电子厂里面电池不是要涂浆料，涂浆料有做手会有机器的12代，那么就是要设计机器的流程，那能够涂得更均匀、更稳定，那个都要用一些公数也有理去算，那你用电脑算的。但你要知道这些公数的，你知道你输入参数是什么，它可能会得到什么，你要有方向，不知道，给他们要设计，他们跟那个台湾最大的固态电子叫辉能，在做它的设计。对，那个数学来先计算跟流程。他讲你设计出来也不会偏差太多。我跟你讲，我们学这些东西这些东西就是让你预测的更准。比如说老师，这个东西学了之后，它真的到实际应用上面真的一模一样吗？不会一模一样，一定都是你会先设计一个大概方向，比如说反应器大概多大，我这个配大概选多大或者什么，所以设计出来你的反应概率是大概选大概2公分大小，就不会选10公分吧，都很坚持。OK， 对不对？你选算2公分，那实际可能做个实验，2个实验嘛，你把它做起来，算一2.2公分，就很厉害，不会差太多。要选2公分的触点，更20公分里面，总有多少可以坚持。OK， 就学这东西呢，就是让你以后呢能够方向走对，不要走偏路，这很重要 跟手边网络，就是大概可以预测这是对的方向。会培训很重要，